Hi students, welcome to a new lesson or a new topic. So today we'll discuss the topic that is aldol condensation, which is a very famous organic chemical reaction, which is under in your chapter that is aldehyde and ketone. And today detailing we discuss the concept of aldol condensation or the chemical reaction or the mechanism that is involved in this reaction. Okay, so I'll just begin. What does aldol condensation? It's my major question. So, an aldehyde or a ketone that containing at least one alpha hydrogen. Okay, that undergo what process? The self-condensation process in the presence of dilute base. There's some terms that is not familiar for you. And first one, aldehyde and ketone. What does aldehyde and ketone? These are organic compounds. So that is carbonyl compounds that are called carbonyl compound. That means in that compound, you will clearly observe what a C double bond O. What you observe? A C double bond O. If one of the side of the C double bond O is satisfied by an alkyl group or an aryl group and the next side is with hydrogen, which is known as an aldehyde. Oh, I think you know that. Then our C double bond O, the one of the remaining edge is satisfied by another alkyl or aryl group that is also known as ketone. These both are what carbonyl compounds. Okay, and that contain at least one alpha hydrogen. What is this? Alpha hydrogen. That means the carbonyl group, consider the carbonyl group and the next group. What is the next group? I just write a CH2 here. Then this one is the CH3 and here is H. We know that this is an aldehyde. Okay, and what is an alpha hydrogen? That means the next atom, the next carbon very near to this carbonyl group. Okay, the next carbon very near to this carbonyl group that contains the hydrogen, that is the alpha hydrogen, and this carbon is known as alpha carbon and the hydrogen that is attached to this carbon which is known as alpha hydrogen. Okay, clear. An aldehyde, what is an aldehyde? You know that. And what is a ketone? And that contain at least one alpha hydrogen that undergoes self-condensation reaction in presence of a dilute base. Okay, and this reaction is known as aldol condensation reaction. The obtaining product that is an aldol. Okay, the initial product of is a beta hydroxyaldehyde or a beta hydroxy ketone and which is known as aldol. Okay, from this name indicate beta hydroxy. Hydroxy means which functional group? That is OH. And what is aldehyde? Aldehyde, that means the CHO group is there in the compound. If both OH and CHO are in a compound, that is called aldol. Okay, if that contain an OH or CHO or not CHO, I'm sorry, then CO. Okay, ZO or R dash. Okay, both containing OH and C double bond O. The ketonic stage is also containing and the compound is known as aldol. Okay, on heating this aldol, the obtained aldol on heating they are usually lost or they undergo a dehydration reaction. We just called it as a dehydration. That means aldol usually loses what? The water content that is present in it and to form what? Alpha beta unsaturated. What does mean by the terms saturated and unsaturated in chemistry? In organic chemistry, I'm only discussing the terms in the point of view or in organic chemistry. So alpha beta unsaturated, that means there is a double bond or a triple bond. These compounds are unsaturated compounds. If a single bond compound, that is a saturated one. Okay, just understand the topics clearly. And alpha beta unsaturated carbonyl compound is the final product. Alpha beta unsaturated carbonyl compound is the final product. Here, I'll give an example. Okay, here I'll give an example. So that example we will discuss very clearly and very detailedly through our class. Okay, then here the conditions. First one, you must remember that the reactant must be a carbonyl compound that must have an alpha hydrogen. Okay, the commonly used base is dilute sodium hydroxide or dilute potassium hydroxide. What are the steps involved in aldol condensation reaction? In the very first step, the formation of an enolate ion. I'll discuss the term enolate detail through our class or from later. And step 2, that is a nucleophilic attack of the enolate on another carbonyl molecule. And in step 3, the protonation that gives the beta hydroxycarbonyl group. Okay, beta hydroxycarbonyl, that means either it is a beta hydroxy aldehyde or it is a beta hydroxy ketone, which is known as what? Aldol. Clear. And in the step 4, dehydration on heating that gives the alpha beta unsaturated products. What is that? Alpha beta unsaturated product. So here I'll discuss the first step of this mechanism, that is enolate formation. What is that? Enolate formation. That means when ethanol, that is an aldehyde. Okay, just that is an aldehyde, that is CH3CHO. This is methyl ether. Total number of carbon atom is 2, so which is known as ether. The root word is eth. And CHO, that is aldehyde, and what is its term? What the term that is added to the compound, that is al. Okay, this is ether, single bond is here, ethane plus al. So what the term? That is ethanol. Okay, ethanol is treated with base. Base is sodium hydroxide or potassium hydroxide. We are taking the hydroxyl part here. That means OH minus part here. Okay, then the CH3CHO is reacting with OH minus. What happens? This OH minus that abstracts the acidic alpha hydrogen. That means what's the importance of alpha hydrogen is here? That is more acidic. The abstraction of that alpha hydrogen atom takes place here. Clear? When, look at here, this is CHO and this is CH2 and here I represent the H. Just consider this is the alpha hydrogen. Okay, that alpha hydrogen is abstracted by whom? This OH minus ions. And to form what? Water molecule. And to form what? Water molecule. And the remaining is the enolate ion. That is also resonance stabilized. That is resonance stabilized. That means that enolate ion has some resonance structure that is that is a stabilized one. Okay, then the step 2, that is the carbon-carbon bond formation. The enolate, that the first step product, that is the enolate, which act as a nucleophile. What is a nucleophile? That is a nucleus loving species. Nucleus loving species. What is the charge of nucleus? Nucleus containing positive charge. So a nucleophile means must containing a negative charge. Must have a negative charge and attacks the carbonyl carbon of a second ethanol molecule. Okay, we take another ethanol molecule which is very familiar to you, and this is the next ethanol molecule, and that is reacting with this nucleophile. Okay, and what you got? Okay, what happens here? The new CC bond is formed. The carbonyl pi bond of the attacked aldehyde is temporarily converted into alkoxide. That is a new CC bond formation. How it takes place? Okay, let's begin. This is CH3CHO. What is this? This is ethanol molecule. We can represent this as CH3 C double bond or H plus. And what is this? This one is what? Inert ion. That is CH2 minus C double bond of H. Clear? Here, a transfer of this two from this, the transfer of these two pi electrons, the bond is shifted as charge here. Then it forms what? CH3 Z single bond O minus H, and here this carbon contain a positive charge. And this carbon is attached with what? This inert ion. Okay, and form a new CC bond. That is here CH, this is the CH, and this one is minus, and creating a bond that is in between them. This carbon and this CH2, this carbon and this CH2, and the new bond is formed in between carbon and CH2. Okay, then CH2 Z double bond of H. Clear? This is what? A new carbon-carbon bond formation step. Is it clear? Let's move to the third step, and this is my fifth slide, sorry. Okay, and this is the step 3, that is the aldol formation. So what will you observe in the previous step? A new CC bond formation, or we can call it as the alkoxide ion formation. Okay, and the alkoxide ion that abstracts a proton from water. Okay, which is ready to abstract what? A proton, because there is a minus charge here, and this minus charge can't undergo a bond formation with this carbon and to become a double bond. That is not a possible step. So that is ready to accept a proton. Okay, let's begin. CH3ZH single bond O minus single bond ZH2 ZHO plus water. Water containing which ions? H plus and OH minus ions. The negative charge that is visible in the oxygen side, that is abstract this proton easily and form what? The product. What is the product? Simply we can write that as COH, then CH2, CHO. Clear? And this containing an hydroxyl part and also an aldehyde part, both are in the same compound, so which is known as aldol. The product is 3-hydroxybutanol or an aldol. This is called an aldol because it contains both aldehyde group and an alcohol group. That's why it is called aldol. Then the fourth step is in our mechanism, that is the dehydration process. Simply the dehydration. On heating the beta hydroxyaldehyde, that loses what? That loses water. Okay, here we supply heat. What we supply? We supply heat. So that the water is removed. Water is removed. Where the water is removed? That's a very interesting question. Look here. This water is removed. The water containing what? H plus and Okay, water containing what? H plus and OH minus ions. Okay, water containing H plus and OH minus ions. So water containing H plus and OH minus. So we can represent it like that. Okay, CHO. Okay, from here. So here CH3, CHOH, CH2, CHO. For water formation, which are the ions are responsible for the formation of water? H plus and OH. From here, OH is eliminated. From here, out of this 2 hydrogen atom, 1 hydrogen atom is eliminated. Then resultant here, there is so many type of reactions can take place. Either it is a free radical mechanism